getting people to kind of like buy something just out of principle is a very small market. And there has to be like actual value and a reason why they acquire it, right? And because it really requires almost a religious, let's say, conviction to use them on a daily basis with all the different problems and issues. And that's
So
pretty much it.
so basically the same as Linux on desktop, right? Like
Yeah, pretty much Linux and desktop and Web2 versus Web3.
and we're live again. Welcome back to all 3 million of you who are listening.
I think
We've
we're about at 4.5 now.
Right, yeah. We've started this thing where I saw it on some other podcast where they would just state outrageous facts supposedly about their podcast in the beginning, and I thought that was quite clever. They would just every podcast would start with like the most popular fintech podcast on the planet. And actually they were doing like, 1,000 listens. um Anyway, today we're doing something a little bit different. It's actually our second guest. We have a good track record of having guests who are not very blockchainy, and also we don't have them very often. But Carsten Munk is here, who, as I understand it, is now the on the board in the Cartesi Foundation. We'll talk about what Cartesi is. The CTO of Zippy, and you used to be CTO of Jolla. Was it a Linux-based mobile operating
Yeah,
system?
yeah, it was a Linux-based mobile operating system, and we actually shipped a few devices, like two mobile phones and a tablet and some other things. But it's a long time ago. Like my own history with this was basically being back in what 2009, something like that, where Nokia were doing kind of like their first internet tablets, where they are doing Linux tablets and involving kind of like the open source community in this. And it was basically compared to something like Android to actually running like an actual like, kind of like embedded Linux system. And I got into that community and started working with Docker on the main Micro operating systems. Then Microsoft came along and some other people, and everything went to hell. So I went out together with some more people to kind of like continue the Linux mobile story, where we built Silfish was a small company of 120 people. And originally started not as a founder of the company, but kind of like, it's a technical lead in terms of systems architecture and mobile and open source and community and those kind of things. And then around 2017, I got bit by the blockchain bug, also because I could see how this would transform kind of like every experience in mobile and on the web. And started the company Zippy together with my co-founder. And we've always kind of like looked at what can you do to kind of like bring value to, let's say, real life use cases. How can we embed, how can we onboard people to Web3? How can we deal with making it easier for people to approach developing for blockchain and Web3? And well, I'm still doing that, but also as part of that, CP is participating as a grantee on the Cartesi Foundation, where we're doing some stuff around, for example, running Linux and zero knowledge, and a couple of other kind of like curious things about kind of like doing various like computation.
Yeah. So we'll get into all that, I'm sure, in a sec. But I want to quickly touch on this this Linux on mobile thing. So um where is Linux mobile, and why did it never come out in any form?
I think it's come out in every form, but the problem has always been that people love their experiences. Like a phone is a very personal thing, right? Even the set of applications that you have on your phone is very personal. And it takes a lot to kind of like move your digital life from, let's say, an ecosystem like Google or Apple with iCloud, and all your family pictures are probably in iCloud, right? And getting people to kind of like buy something just out of principle is a very small market. And there has to be like actual value and a reason why they acquire it, right? And I can make maybe a little bit of an experience, like comparison, for example, to why initially, let's say that many people didn't adopt smartphones, for example, a place like Kenya, not because they couldn't afford it, but because it didn't necessarily give the return on investment for them to have it. As things like WhatsApp came out and so on, then that changed completely the equation, and people actually started acquiring smartphones and they loved WhatsApp. So that's kind of like the reason why Linux and mobile is not as popular, because it really requires almost a religious, let's say, conviction to use them on a daily basis with all the different problems and issues. And that's pretty much it.
So basically the same as Linux on desktop, right? Like
Yeah, pretty much Linux and desktop and Web2 versus Web3.
yeah, it's like if you want to spend your days trying to figure out why your Bluetooth isn't working, then you should be on Linux.
Yeah, exactly.
Yeah, let's not go down that rabbit hole because that could be the whole call, I think.
But yeah, anyway, so from that background, like I do want to just move towards Cartesi a little bit. So like, what is it about Cartesi that, or Ricardo, did you have
Or
another
actually,
idea?
before we even get there, for the people who just look at crypto and say, this is a company or this is a DAO or what have you, perhaps it might be better to even start with what does a board member do on a foundation like this?
So when it comes to kind of like Web3 kind of things, so like as you might know, with let's say different foundations and different organizations or even companies, like in a foundation, typically a board member there is kind of there to make sure that that thing can continue along the mission, that the money is spent according to kind of like why this foundation was set up, right? And in general, kind of like safeguarding, a little bit like a trustee to some extent, if people know that term. And in Cartesi's case, it's interesting because Cartesi is like it's a decentralized ecosystem, right? And it feels weird to kind of have something centralized in a decentralized ecosystem, right? But there's always kind of like touch points where a decentralized ecosystem might need kind of like to interface in with, let's say, the normal legal world, like for example, owning domain, paying for servers, if such are needed, or infrastructure, interaction with the bank system, which is something a DAO, as a man, let's say, a decentralized organization typically can't do. So in Cartesi's case, it's more like, let's say, protecting kind of a treasury, making sure kind of like things like the trademark and so on is used correctly, and in general, just being just another participant in the ecosystem, particular case. So my kind of like my day to day as a board member is not that different from being part of a organization. We are, let's say, of course, discussing, but also, let's say, facilitating that things can happen.
Right. So the foundation is kind of like a traditional world multi-sig.
Yeah, exactly. Yes, and that's quite like a good way of explaining it.
But so yeah, maybe let's just go over what Cartesi is. So maybe it would be helpful if I sort of try to summarize what I think it is, and then you can correct me and explain what it actually is. But as far as I understand, basically, Cartesi is a Risc 5 instruction set emulator, which you can run Linux on, and the main kind of differentiator to just being a random instruction set is that it's provable in this like game theoretic game that resembles um, the dispute resolution system and say optimistic rollups, and that allows you to run kind of anything that you could run on Linux, and verify it in a sense on the blockchain,
Mm.
um, on some blockchain, and we can get into which blockchains.
Yeah,
But
exactly.
is that about right?
Like it's about right. Like what you're talking about is that of course Cartesi is more than just a single technical, right? Like there's the Cartesi machine, which is like the virtual machine of the Cartesi ecosystem. In this particular case, it's a virtual machine like the Ethereum virtual machine, where you can pretty much assume that if you put some input into it, some code, it will run exactly on the same way on every single node that runs, right? So it's a deterministic machine here. But compared to, let's say, something like the EVM, what the Cartesian machine is implementing is much closer to actual, let's say, a real computer. Like it's a real instruction set that you can use the last 60 years of, let's say, compilers, languages, uh, tooling, debugging, environments, because essentially there's actual real hardware that also implements this Risc0 instruction set. Like you can literally run Ubuntu inside this thing, right? And where, let's say, blockchain has kind of like been struggling, in my opinion, is that it has not been very easy for people to get into it. There's a very big leap between what they already know, which is, for example, I can upload a Docker container with JavaScript inside to a cloud I can interact with, right? Like that's kind of like the story here. And with something like blockchain, it's like, okay, I need to know Solidity. I probably will end up in the end of the day, like everybody does, to handwrite some EVM opcodes into the facility, and I have to constantly optimize for gas. So it's like a tiny embedded system to some extent. And what Cartesi enables instead is to, hey, you want to run Linux? You want to essentially run, let's say, something that you can already use on cloud today? You can, right? And that's kind of like the power here. What then sits beyond the Cartesian machine, of course, is like where it then becomes more like, let's say, something like optimism arbitrum, where you can actually, let's say, deploy, let's say, a rolled up on app chain or something like that using it, and actually take this stuff that you have developed, put into a, let's say, trustless container, or how you will call it, which is the Cartesian machine description or something like that, and actually interact with this like you would interact with a blockchain. And that's something I think is very powerful. And like back in 2017, when I myself kind of like started with Ethereum blockchain, this is kind of like what I hoped it would actually exist, because it's much more general purpose. It's much easier to work with. And I can also, let's say, from a more kind of like engineering point of view, uh, junior developers who can write JavaScript is much cheaper than Solidity developers. Right. So that there's also a kind of economic angle to it, that you don't need to have an entire startup to kind of like make a interesting use case.
Yeah. So I mean, I think like a part of that, or like what interests me in Cartesi and in some other things like Risc0, which we'll probably discuss as well, is that I suspect that for Web3 to actually win in any real sense, it needs to start looking and feeling more like Web2,
Mhm.
which is kind of counterintuitive, but like it just doesn't make sense to have a completely new everything. Like it's too much of a hurdle to get serious adoption. Like there's always going to be things that need levels of optimization, which will require going like either very low level or whatever it is. Like let's take, I don't know, the Cairo VM from Starknet. Like if you want to have provable compute and you need maximum efficiency, then you probably want to be writing Cairo directly, or something like that. um but then if you want people to just start working with it, like the Web2 stack is not perfectly optimized for most people either. Like some
Yeah,
big organizations go very low level and optimize, but mostly people don't, because it's just not worth it on the
right.
abstraction
It
side.
is not worth it in the time spent to actually develop it, right? Like it is like you will optimize on the things that is being hit let's say every single day with your transaction handling and so on. But in most cases, like getting faster to market is actually what matters, right?
Yeah.
Yeah. I mean, I generally agree on the fact that we need to look a little bit more like the web, or at least be closer to the Web 2 stack. Let's say which is something that
Like so closer to cloud computing to some extent, like
Yeah.
like computing like we know, but still using the strengths of blockchain, right?
Yeah, that I generally agree with. The say that I think that the issue of saying like, oh, junior node developer is cheaper than a junior Solidity developer is a little bit of a fallacious comparison, because what you really need to bring in is the mentality that this type of apps require. And even if you could write, and maybe we're getting ahead of ourselves, but from what I've seen, you could write a app on any arbitrary thing. Here, like the examples that you have on the side are on Python. The things that would cost, like the foot guns, basically are still all Web3 foot guns, right? So those are the things that really have a cost to mentally acquire, let's say.
Yeah, of course. Like there's for sure certain kind of like specialities that require better handling, like better proving and so on. But it's a little bit like just like specialized pieces of software or services and so on, right? Like there's some place things like, let's say, kind of credit card processing is like a surprisingly hard problem, right? And that's also why programmers drivers use so much time on really specializing in dealing with all these ancient bank systems. So I'm not like advocating that we need to run, let's say, our token ledgers in PHP, even if that is possible. But it was certainly be quicker to get to market, right?
I mean, I would love to see some crypto project write their whole thing in PHP. That just like for nostalgia reasons, bring in some of those like 90s coders who think PHP is the absolute bee's knees and have them write the best possible program. But I did want to ask, so like Cartesi is like provable in that sort of game theoretic sense. But what always, or like what up until this point generally has been the problem with a lot of these types of things is like you can have the environment be, you know, very scalable in and of itself, but then you have the fact that you need to actually put or like do that either proving in the zk proof use case or in this do the dispute resolution on some L1. And then that L1 is the inefficient one where everything costs way too much. And that kind of kills a lot of these use cases for like most things. So I guess the question is like, what is the idea here in terms of like posting or verifying data on some blockchain? Because if you do it on Ethereum, I would imagine that a lot of the most interesting use cases that you could do in a Cartesian machine basically go out the window just for cost reasons.
Yeah,
of course.
Like this is the thing about like just so people understand kind of like what the problem is here, that posting data to the Ethereum blockchain costs a lot of money, right? But essentially what that does is that anybody can go out and replicate the computation, right? Because I'm posting what I'm putting into my virtual machine of input, and then I can trust that everybody is able to kind of like find over what let's say, the result should be, right? And that's kind of like how these optimistic systems work, that because everybody can kind of compute the same thing, they can also defend, let's say, what the result of that computation is. And the problem with, of course, with Ethereum layer one is the computation is expensive because, well, it's a singular thread of very embedded like code, essentially. And what is then changing with things like layer twos is, yes, data availability is still expensive, but now it's compressed, so it's a little cheaper. Or that you're just kind of like publishing the differences in the states or something like that. But computation is a lot cheaper, right? Because you don't need to kind of like run things in a completely, you don't need to finish a block in 12 seconds anymore. It's just something you can kind of like snapshot in and kind of like prove over time that proof to that underlying blockchain that this computation has happened, right? So that's where topics like data availability, which is a terrible term that we can discuss that later, and data publishing comes in, that you can kind of like prove that you have really tried to spread this information to as many people as possible, and then prove that to a blockchain that you did by things like sampling. This is, for example, how the whole prototype sharding, which is also a terrible name, is doing. And basically, that enables that both computation is cheap and data gets cheaper, right? Like there's still a cost to come. If you want to put something on board across all over the world with a satellite network, there's a cost to it, right? But kind of like the price goes down.
So, but in sort of the optimistic verification game setup, you need to put a lot more data on chain, don't you?
Yes. Like in terms of like, you need to have the input data on chain, right? Without holistic setup, because otherwise you can't replicate the computation. This is a little bit different with zero knowledge proofs, where you can kind of hide the data. And then instead what you're publishing is that everybody has at least the same starting state from kind of like the proof that they're making. Some ZK EVMs are kind of like actually publishing the traditional transactions that to chain, and that kind of like matters to them, right? But let me take an example of something where it's really, really difficult today to compute on even, let's say, optimism. For example, there's this special type of there's a particular signature type that's used, for example, in iPhone and Android, which is using a little bit different elliptic curve to kind of like sign data, right? And it's quite useful because you can kind of like sign with your mobile phone in existing browsers. You can do things, right? In current EVM and even the optimistic EVM version, it's super expensive to go ahead and actually try to verify these signatures. But with something like Cartesi, you can actually go out and essentially compile the signature verification for that, which is very, like the signatures in a very, very small amount of data in this particular case. But we can go out and verify that, for example, a Cartesi machine is much easier to kind of like develop and actually get working. So even if there's limited amount of data, there's still kind of like a use of much more general purpose kind of computation.
Yeah, so you don't need to wait for like Ethereum to add a pre-compile to bring the price of some signature verification down. You can just
Yes.
start doing them. That makes
to
sense.
3 to 4+ years of waiting on BMS signature verifications with the right curves, it's not going to happen.
Well, you need to think about these things on kind of Ethereum's timelines, which are measured in centuries, not years.
Exactly. But I also see that when it comes to kind of like data publishing and data availability and sampling and so on, like the more we get, let's say, stronger and stronger restaking networks, like with Eigenlayer and so on, the probability that this data is actually not available becomes so small that it doesn't matter. I mean, even a blockchain is to some extent probabilistic, right? In terms of kind of like that it reaches the right result and so on. So I'm seeing that kind of like these things will start going away.
So I don't know if we should stick with Cartesi. I'm
We can go
like,
all over.
right.
We can go all over the verified compute space, I think.
I'm right on the verge of going down the data availability track, but
Yeah, let's actually still talk a little bit more about the whole Cartesi setup, because like there are some things that are not entirely clear to me, having gone through the docs. For instance, just looking at it from a completely setup environment, from a development environment setup, it's quite good that, from what I understand, like if you're just rolling up a dev state, that's kind of like a local rollup. What is entirely clear to me is if what you guys see for the end state of once applications are developed, is this like one tap, one rollup? How do you see this evolving?
So I think that to some extent, I don't really like the term roll up either. It's a nice technical description of that something that's sort of like kind of like it's posted and anchored into Ethereum, and it, let's say, the database is available. I'm not completely sure that most use cases is captured by it. I mean, at the end of the day, what we're doing is making computation of incoming transactions over a state, right? I mean, that can come from any kind of like way. But what I would what I personally would like to see is that I can sit somebody down at a hackathon or something like that. They can go in to Cartesi website. They can download a convenience tool, a little bit like, let's say, Fly.io has with their cloud. They can take a Docker container sample of this stuff. They can code their stuff up. They can deploy it to a network, to the network, and essentially being able to, let's say, to pay for, let's say, the existence of their particular little chain, right? I mean, that's the kind of like dream. And also what, for example, let's say arbitrary wallet is kind of like going in direction of, then I can literally go in and press a button and I have my own damn roll up. And
So just to dig into that, so is the idea right now, I obviously these things change, and like anybody who purports to have a clear vision for where the stuff is going is probably a liar. But
or insane, one of those, yes.
or insane. I mean, you can have a clear vision, it just might be incorrect.
Yeah.
Probably is incorrect. But so is it to sort of anchor these things onto Ethereum or other L1s, or like how kind of like generic are you trying to make it? So is it that I could spin up like an Ethereum roll-up-y thing, a Arbitrum roll-up-y thing, Polkadot roll-up-y
Mhm.
thing? Like, is it sort of everything?
So in general,
or
like
just one?
this, in general, the stack is, let's say, very Ethereum fixated, right? Because I mean, it's also the strongest proof of stake network out there in terms of like security and so on. So that's kind of like you want to anchor into that. The Cartesian technology itself is naturally not limited to being in just, let's say, an Ethereum environment, right? Because like if you want to just follow the incoming blocks coming to your rollup, I mean, there's no specific EVM directly involved here. You're just collecting data from several, which might happen to a very green Ethereum chain. So, but the thing about where you start to need to, let's say, prove something about kind of like the end results of your computation on your rollup and so on, the state of a blockchain, that's where something like, let's say, smart contracts and bridging and verification games kind of come in. And the good thing is that like, let me make an example with Arbitrum, right? Arbitrum has a WebAssembly VM, and they have had to go through a lot of kind of like hoops in order to make this one judge on chain that proves a certain WebAssembly step, basically, because like the way that this kind of optimistic thing works is they kind of like find out where do you disagree, and then when you have narrowed down that point, you ask the blockchain, okay, which one of us is right about what the next state of the machine is, right? So they've implemented basically a larger subset on kind of like the Wasm virtual machine is solidity, right? And it's not a simple thing, right? Like how do you actually audit that? How do you make prove that this is correct? And where I like what Cartesi has done in this area is that basically they took the exact same code in C++ that runs a small instruction set, which is like a typical Risc0, very small instruction. They're not trying to emulate the whole machine. They tried to do that once. They're not doing this anymore. They're kind of like doing something a little smarter. And the C++ code that has been verified and tested through all the Risc0 test cases and compliance and so on is extremely similar to the actual Solidity code that actually comes in and kind of runs this one step, right? That same code can then essentially, because it also exists in C++, it also might exist in Rust. You can compile that into, for example, a Wasm chain. There's no reason why you couldn't run this kind of verification game or file called VM, for example. And also the virtual machine itself as as the presentation I've done before about running Linux and CK, can actually even run inside another, let's say, a CK VM. So the technology itself is not, let's say, limited to Ethereum, because even as we look forward, Ethereum, I think, essentially will be around extremely high value assets. It will be around very high value data availability, proof of stake, and restaking, right? Like that's kind of like the baseline of Ethereum in this particular case. Then there will be, on top of that, there will be many different kind of like, let's say, virtual machines, roll-ups, small chains, sequences, data availability layers, and so on. And that's kind of like where you need this flexibility of technology, right?
So what I didn't quite understand is like if you're not implementing basically the instruction set in the smart contract and running that one step, what are you doing?
So in terms of, sorry, could you repeat the question, like in a few phrases?
So for the verification game where you implement basically the instruction set, so in the WASM use case, you would implement like a small WASM runtime kind of thing, and in this case, I guess you would implement the Risc0 instructions in the smart contract. Um, I didn't quite understand. Like, is that what you're doing, or were you doing something else? I didn't really understand the
Yeah. So this is
solidity
yeah.
comparison.
Yeah. So the point here is about auditability in this particular case and readability. So what Cartesi needs to do is being able to have a very, very secure verification game, right? In general. So it matters that there's something very simple that people can take a look at, and by judging what they know about solidity and so on, they can implement this verification game like this like they might be able to implement, but they can like let's say feel to themselves that they actually trust what's here, right? Because it essentially is like how an implementation of a Risc0 small processor would look like.
Yeah.
So what I'm saying in relation to kind of like how this is flexible to other things is because that implementation is, it's literally like less than 400 lines of code, is very transparentable onto other kind of environments, like let's say inside of Risc0 ZK inside Filecoin VM. You could probably compile it to BPS in Solana if you wanted to.
Right. Okay. Yeah, I see. But you are so the Cartesi does implement the Risc0 instruction set as a
Yes.
solidity smart contract,
Yes.
and then when there's a dispute, tries to hone in onto the specific step
Yes.
that is disputed, and then it like simulates running that instruction on
Yes.
Ethereum or wherever it is. Okay. Okay. So in this future where there's kind of like Cartesi machines all over the place, depending a little bit on the use case. What is sort of like is are is the Cartesi ecosystem linked together in some way in this future? Like, is it a network of some kind? I don't necessarily mean a blockchain, but like if they're like, I know that you could have a Cartesi machine that's anchoring on Filecoin and another one anchoring on Ethereum, and they have nothing to do with each other. But is there some plan to have them do something? Like, is there some interaction between these different sort of Cartesi machines
Yeah.
running around in the ecosystem?
Yeah. So this kind of like the interesting thing about a decentralized ecosystem, right? Because like how do you define a roadmap for a bunch of people that are kind of like pushing in general direction of a mission around verified compute, right? So like naturally I can't say that what's something is in plans, right? But naturally, as you're, let's say, if we are currently at this like stage of that you're kind of like rolling out, like allowing people to, it's like right now, Cartesi the main product is like a roll-ups framework, right? That uses the Cartesi virtual machine of the machine in this particular case. It's kind of like just singular kind of like machines, right? That kind of running out and so on. But I personally believe that there's a benefit to having, just like with smart contracts, right? Like there's a meaning to that you're kind of sitting inside an ecosystem and kind of have common protocols and so on, proximity and latency, or in probability, or even security, that you can kind of interact between these machines. And I think that probably eventually emerges as something like a network or a computer or something like that. So that's kind of like a little bit my non-answer on this, that I think that kind of like as things evolve, like if there's more and more people adopting this, the more and more kind of like that there will be reasons to collaborate, kind of like somebody, let's say machine to machine communication level. Like it's a little bit like data availability layers, and a little bit like network interfaces between different Cartesian machines.
Yeah. Well, I mean, as I've said to you in the past over Telegram or something, like I do see a future in which like there is an L1 construction which is optimal for optimistic verification games, and it's not any existing construction. And I've talked to some other people about this, and the general response I get is that people don't really want to build L1s for whatever reason.
Well, it's
Uh,
also because it's gotten a lot more difficult to raise for L1, right?
yeah,
Like my personal belief is that as the design pattern of restaking, which Eigenlayer is, came in, it effectively combined with the regulatory environment and everything else, basically killed the reason to make most of the other L1s, no matter how technological advanced they are, right? As in that people were kind of like bootstrap using existing, let's say, Ethereum security. There's a lot of debate about this, but I'm allowed to have my radical opinions.
rather than saying you're of course allowed to have your opinion, and I like there's some truth in that side, but I do think that a large part of why people are going so much in sort of the restaking eigenlayer direction is because like that's just a more compelling story to VCs. It's easier.
Yeah.
L1s are scary and difficult, even though if you look historically, they've returned orders of magnitude more than just about anything else. But it sounds easier to do something with eigenlayer.
Because you can like instead of kind of like focusing on token price and so on, you can focus on actual stuff that brings value.
You think these guys are not doing tokens?
Of course, they're doing tokens in one way or the other.
They're doing tokens, but they have less of a reason to have a token, which arguably makes things worse. And their entire basically like consensus system, or like not necessarily consensus, but their staking system is implemented in Solidity, which is probably a bad idea. So to be clear, I think restaking is very cool, and I think Eigenlayer is doing a good job. I do question whether you wouldn't want to implement that in some other system, though.
Well, that is also kind of like the question here. So like that also comes down to a little bit the discussion about off-chain compute, right? Because how much of this, let's say, because yes, the staking system is implemented in Solidity, but that's because the funds end up in, like the funds when withdrawn from the beacon layer ends up in a Solidity smart contract, right? And in order to prove that this person should be freezed, person, or however they call it, we need to prove it on layer one that this person should be flashed, which means implementing this in Solidity, right? If you can get into a situation where, let's say, I can maybe make an immediate reason that I'm likely to publish a proof of that this person should be slashed from some off-chain computation, that might actually change things around. I think that we haven't really fully explored these design patterns just yet.
It's quite likely that using restaking, you need to have all the complexity. I mean, it's fine, but like having all the complexity of either a verification game or a zero knowledge proof in order to have that work in general. And at this point, like I don't think we still have even like forced exits um, for users, though it's a little bit different maybe because this could be protocol level stuff. But the main concern is like, great, you're restaking. I understand why you want to do that. It's like a much larger pool of capital that you don't need to try and bootstrap from scratch. Um, but you are constraining yourself and your design space again because you will be constrained by Ethereum's performance and fee structure. So like this is, if you look at the rollup landscape now, like 80-90% of all costs from rollups are L1 costs, and like it's still more cost efficient than doing it on L1, obviously. But like if we imagine that the industry is gonna grow like an order of magnitude, that's not gonna be anywhere near enough. So, but I don't know. I see what you mean, but I think a lot of these things are kind of VC narrative driven more than optimal system design driven.
Yeah, and also like natural people who are running validators on Ethereum, they also need to feel that by being a validator that they have their fees covered no matter what. And then the question is like do they need to go out and run kind of restaking services in order to kind of like stay profitable? And so there's no never a boring day in crypto, right?
Yeah, and by the way, just to be clear, all of this relies on dank sharding, like coming out in the next. I don't know, like the roadmaps of most rollups include like full launching
Yes,
stuff
this
yes,
year
which
or next year.
which is why I my personal stance is, and this is no official position of anybody's except my own, is that prototype sharding is not going to give us the boost we need. It will give us a very nice pre-compile, which allows us to check KZG commitments and point evaluations and so on, which will ironically likely enable all the kind of like probably better restaked data availability layers, but prototype sharding itself, because of what I consider as Ethereum's aging P2P layer, is not going to be the magic bullet we're looking for.
No, I mean the ZK Sync guys did this calculation, and they were on Twitter talking about it. I think just last week or the week before that, and they calculated that with proto-dank sharding, like maximum utilization L1 and L2s, the total transactions per second capability would be somewhere in like the 200 range.
Yeah,
which is better.
which actually got
To be
cooked down
clear.
it got cooked down to 70 after a while.
Oh, did it?
Yes.
Okay. So okay.
And the problem is that there's a metallic post out there somewhere where if all this EVM equivalence thing came out and people discussing it, where like oh, but you can do a unit swap transaction in, let's say, 12 bytes, right? But then still EVM equivalence kind of thing came along, and then, well, I want my transactions to look like typical EVM transactions, right? And then it's not going to be 12 bytes, it's going to be whatever 1600 bytes that a Uniswap transaction takes, which means that it's effectively 70 TX per second instead across all roll-ups. So yeah, it's
not
like
great.
it's not fantastic now. I would like to argue that the whole KCG ceremony and the opcodes is a positive outcome of this, but the actual network, except for extremely high value assets like that, it's not going to help.
Yeah, and it's a little bit unclear to me how L3s would actually help, assuming that they're still also posting data. Because then that data just basically goes up the chain, right? So like I understand if you have an L3 where you just don't post data anywhere, then sure. But if you're trying to like verify up the chain, you will need all the data, right? Like you can do some recursive proving along the way in ZK rollups or validity rollups, but you still need the data.
Yeah,
Like
you still need you still
need
need
the
the
state
data.
hash.
You need the data, but I think the difference in this particular case is that whenever we are selecting kind of like data availability networks or let's say proving and so on, it's a lot cheaper. Or we can kind of like establish kind of like different kind of like assumptions because computation is cheaper on the layer we're posting to.
Right.
Like, for example, there's no reason why I couldn't implement, let's say, a particular compression algorithm or something like that. And it's cheaper because it's, yeah, like a very huge dictionary or something like that.
Computation can be cheaper, yes, but I'm not sure that the data side kind of remains regardless. And I would assume that in a lot of cases that's a majority of the, or not a majority of the cost, but significant. But that's fair. So you can get efficiencies in computation, but they don't necessarily generalize to data as well. Um, maybe this would be a good before we get dragged down further into this rabbit hole. And I have a lot of views on this, which I'm not going to share yet because we're announcing something on this Monday that will probably highlight some of them. But you have some plans in Cartesi. Oh, sorry, well, not Cartesi, but you specifically have been um, tweeting a lot regarding basically proving Cartesi machine with Risc0. You want to talk a little bit about that and like
Yeah, so
why?
maybe yeah, why? That's always a good question. But so just to kind of like recap to people who like things, like Risc0 is a zero knowledge proof framework. It generates stocks as in a particular kind of zero knowledge proofs. And their approach is that they don't have a, let's say, well, they do have their own ZK VM now, but the point here that they have a ZK virtual machine, which basically implements a 32-bit RISC-V machine, like not a complete machine where like you can't run Linux on it, but you can kind of like use a standard compiler like Rust or GC or LLVM, compile to it, and in a more kind of like embedded software kind of like fashion, you can go in and kind of like prove the execution of that program in ZK, basically. Like the proving that it had some input, it ran a particular program, which basically is a RISC-V binary in this particular case. And that program then outputted or committed particular things. And what's lovely about it is that they have very nice developer experience. Like I have a software developer, he learned Rust in 4 weeks, and within 2-3 weeks, she was able to do stuff that people would prefer to hang themselves over than implement in CICOM or in what kind of frameworks. So that's kind of like the level of approachability, right? And this is typical damage Rust, and of course you kind of like include C++ modules or C or whatever else you kind of like want to stuff in there. And on top of that, they also implemented something called continuations, which is basically like typically when you're writing a zero knowledge proof at the moment, you're restricted up to a certain amount of constraints, right? And well, the stereotechnical speaking has the same problem, but what they can do is because they have kind of like this aspect of of the processor, they kind of like chunk the execution into multiple slices and then generate a proof for each of those slices. So from when you're developing, I don't feel I'm constrained to just one zero knowledge proof. Like it will generate multiple of them, but I don't feel it as a developer, which means that I can really focus on, okay, I want to have less zero knowledge proofs and can optimize towards that. And when you kind of combine all that together with recursion or converting the stock to SNOC, which is something like that the few people can do with the online service called Bonsai, then you end up in a kind of quite nice development environment. And one of the things they've done recently is that, as you probably know, there's been a ton of VC money and other kind of like investments poured into certain EVMs where they've been painstakingly implementing or handwriting circuits for implementing the EVM and ZK, which was of course lovely and it's specialized and so on. And there was Risc0 people basically took the Rust S client implementation, compiled it using Risc0, did a few modifications, plus continuations, and basically, well, it works. Right. And well, that's something like that. And it actually doesn't perform that terribly bad, right? And you can always optimize in certain things and make specialized circuits for the things where you actually need to accelerate it. So, that's where they have the benefit of being kind of like a RISC-V virtual machine. Now, of course, compiling the EVM is not crazy enough for me.
So just quickly before we go into Cartesi plus Risc0. So basically, like Risc0 takes the Risc-V instruction set and proves that via CK, right?
Yes.
So anything that compiles to Risc-V within whatever constraints they have, you will be able to generate a proof from.
Yeah.
And so what they did with the EVM thing is they took a Rust port of the EVM, which I'm curious whether it has all the same problems as the real one, but regardless, and they basically compiled that to Risc-V and then proved that. They did then go ahead and call it a Type 0 ZK EVM, which was not ideal. But then, controversy.
Yes, as you're probably going to say next, the like if you put out something that's perfect, nobody's going to care, right? If you put out something that's a little controversial, then you're going to be tons of marketing.
Yeah, exactly. Controversy is great for marketing, but so
Mhm.
that's but what you were saying, I just want to touch on because it relates to the thing we were talking about earlier. So basically, it's like if you want to have the optimal proving for any kind of specific thing, then it's likely that Risc0 is not going to do that. But in terms of an abstraction for developers to work with, it's just really easy and it's not that slow.
Exactly.
Yeah.
And even the things that you find out are slow, it's typically of the kind of like the thing where you can likely have other people that are solving the same kind of problem. Like, for example, needing to run a particular kind of hash type or deal with big integers, calculations, and local accelerations. So you start out like it's much easier to kind of like to go to your boss and say, I have something working, right? And then work your way back towards being extremely more performant over time. You'll get more money if you have something working.
Yeah. Yeah, that makes sense. And I think they have done a good job of having like some like Risc0 themselves have done a good job of having something working. Even though our engineers complain that they have yet to be able to compile it. But they haven't tried recently, so don't know. But anyway, you were so then you thought that like basically like could we take the Cartesi machine which emulates the Risc-V instruction set and then prove that within Risc0?
So the timeline here is a little bit of a lie because basically last year in September 2022, before anybody had kind of like started putting the EVM into, we also tried at that point to put the EVM into it, but there were some issues with Risc0 that like they didn't have continuations. We already in October 2022 put another Risc emulator into it that wasn't really that complete, called it was completely Rust based. And we actually proved a couple of cycles of Linux boot already back then. But because of continuations, there's a lot more things you need to kind of take care of, memory proofs, etc., etc. So when continuations came along, it actually just became possible, right? So with Cartesi, then like because Cartesi is an emulator, right? It's a quite nice written piece of software because all the state of the emulator is in memory as a provable state now. So kind of like that you can start over the hash and prove that pages belong to this memory do X amount of cycles of execution, kind of like make an output from that. And kind of like when you kind of like string that together, then you kind of end up with a proof that, hey, I started up a machine containing a Linux kernel and I ended up with a particular end computation state, right? And that's essentially what we did. Basically taking the Cartesi machine and just basically stuffing it a little bit like putting a cow inside a smaller car into this 32-bit Risc0 virtual machine, and can implement all the stuff account paging in the pages from the 64-bit address space, executing cycles. And I mean, it's slow. Right? It takes, at the moment, it takes 3 days on a single GPU to prove Linux boot, right? But you can then use
Wait. So say that again. How long does it take?
It takes 3 days to prove on a single GPU.
3.
Yes, yeah, a single GPU, yes. But
So
I will also
slightly inefficient.
it's slightly inefficient, but people also call the EVM inefficient, right? Well, they still do, but but the point here is that this was without any kind of optimization, right? And basically, as you kind of like starting to kind of get more and more with this immediate, like for example, you find out that, hey, I can start doing ahead of time proving compilation of this code that I'm actually running on the kind of like the bigger 64-bit machine into the smaller instructions instead. I can start doing tricks because like in a virtual machine, you can offload anything to the host of like the prover that you can verify on the slow one, like display in the circuit or in the guest machine, right? So once you kind of like start actually optimizing this thing, you might actually get much closer to something that's actually really provable to actually use, right? And also, once we have compiled, like built this boot up, like what we're proving this boot up of Linux, we have a proof of that boot up now, right? I can go in the address space of this machine state and kind of like surgically kind of a little bit like taking a disk out and putting a disk in, and then it continues to boot after that, right? So it enables this kind of like that most operations and most proving sessions that you'll be having is actually not that many amount of proof you're actually doing, because it's just a tiny subset of things you'll be doing. Of course, if you want to run ZK PHP on top of this will likely be slow, but even in normal execution of, let's say, programs, like, you don't want to do too many system calls during execution because it causes a context switch, right? So very similar with, let's say, something and emulator stuff inside of ZK4. You basically want to kind of like optimize for these certain moments, basically. So an example like I mentioned in my presentation was that, okay, so let's say that I want to, let's say I put up a bounty somewhere, right? And that I have my piece of software. Here's a Cartesian machine with the software running inside another emulator with x86, right? Like I have my PHP website. I want you to prove to me that you found an exploit to it. And I can then say, I can insert your link and kind of prove that here in the memory that I actually managed to, or in the output from it, I actually managed to get a root console through exploiting it. And that amount of computation is then what I prove to you. So basically, like, there's definitely use cases where even in the most slow variant, there might actually be a benefit to it.
So in that scenario, with the, like say the exploit proofer, the proof that you would be providing would be a proof that you ended up on a certain state, starting from a verifiable original state.
Yes.
Right?
And then once you have that, then it's a lot easier to kind of like prove that indeed I have something. It might improve the bounty market for some of these things. But that's kind of like all still out in the future, and so kind of like explore, but like the expressibility of CNOS proves according to the point that yes, we can run Linux in this and Linux apps, which I think personally is amazing.
Yeah, and this proving you were doing on your laptop or something.
Yes. I was also testing it on kind of like a GPU and so on, but yes, in general.
Okay. No supercomputers as
No, but of course, because some of these things, like a lot of these things might be public verification, of course, but like one of the design patterns we are looking at, that you might have kind of like some part of a Cartesi machine execution that runs in public, then it flips the switch, and then it goes into ZK mode for a while. Then you get into a new state, and you can continue in public, a little bit like switching into kind of like you have a hypervisor and you can switching into encrypted VM as an example.
Could you? This maybe is a dumb question. It probably is a dumb question, but could you? Um, I guess optimism is actually doing something kind of like this, but could you basically have a proof of the disputed resolution that you use to resolve the dispute, as opposed to simulating the
Yeah.
instruction?
Yes. So what Optimism is doing at the moment, as far as I can see, is that they're kind of like implementing at least their one step in zero knowledge proofs, right? But if you have the data available and you have kind of like the time on a timeline of these different events during a verification game, you could evaluate the verification game using a zero knowledge proof, right? Because basically you have a bunch of provable points that we call, let's say, an interior block or another kind of data availability layer. And you can say that, hey, these events happened and these events didn't happen. And because of this, you end up in that this was the result. So you don't even need to involve solidity in this particular case.
Right, but so like, but do you need? My point is like, do you necessarily need a verification game at that point anyway? Beyond like somebody says, "I dispute," and here is the proof of the
In,
sort
in,
of
in,
single instruction being run.
Well, you obviously like that. If everybody agrees, right, then that's no problem. But if somebody disagrees on the computation result, like assume this for a moment is not, let's say, Cartesian ZK, just that we actually prove the execution of, right? It's the public verification here, right? Which could go a lot faster. Then you can go in and essentially prove all the execution that would normally have proved, like let's say, gotten executed in the Spark contract of the layer one, right? You can like prove that, hey, this also arrives down to a particular point.
Mm.
How much that has usage at the moment, like in like benefit, I'm not sure, but like I think right now, Optimism is looking at it not from point of view of the actual verification game. I might be wrong, but about having multiple votes on what does this one step thing actually, let's say, result in.
Hmm.
That's my impression, and I'm not really sure about that.
You may be right. You may be right, but it is interesting, kind of starting to see the optimistic world and the ZK world
Too
sort of
much, but
gently dip their toes into the other.
I mean, in the end of the day, it's not that different because like in ZK, like you're kind of like running a algorithm local on your machine, convincing a verifier about something. So in similar kind of way, we are trying to convince a blockchain that this is the right thing.
This is kind of a random thing, but do you know what the most optimal structure is for one of these things? It's to have a ZK proof of the stake that's optimistically verified, i.e., not verified in most cases,
Yeah,
instead of having verification be re-executed. Like if you think of a sovereign rollup, for example, you would typically right now you would have somebody produce the proof and then everyone else would verify. That's already better than full re-execution. But you could add an optimistic strategy to that where you don't actually um, like force anyone to verify anything, but then you obviously rely on some kind of watchtower or
yeah,
someone to
yeah.
be watching.
I think in these, like, we'll probably start seeing a lot more about, like, let's say, probabilistic certainty of kind of like computation results and so on. Because it is like even with like something that kind of like has encoded into people kind of normal behavior on blockchain is that, well, you need to weigh 7 confirmations, right? But they don't talk about that this is because then there's very, very little amount of chance that their transaction has been reverted, for example. Where this has changed with proof of stake, the number, but that's a different topic.
But so like sort of just in the imaginary space of things you could build, like the reason that something like that would be interesting, like that combination, is because you could literally in the standard case um only have like the prover compute a proof, and all other nodes do nothing.
Right.
So, like standard case would be equivalent to basically a centralized setup. I mean, of course, they're doing a proving operation, but still. Ricardo, any thoughts?
The main one is this: we seem to have strayed far from the Cartesi topic,
It's all,
which is of course our want.
it's all connected, man. Like in the end of the day, like we can finally start, let's say, making blockchain friendly to people again in terms of development experiences, so on and so on. I'm looking forward to when people bring back, let's say, decentralized universal that or something that is actually, let's say, beyond, let's say, just DeFi and answer tokens and so on, like actual useful things, even if it's the tiniest little roll-up running on a L4 or something, or something somewhere, that people start taking advantage of this decentralized world.
So, I wanna ask a question related to that from both of you. I have this sense as well that it would be nice if, blockchains were able to do more than just finance, like computing in general. But then every now and then I think, what is it that we use computers for in the traditional world that's so much more grand and interesting? And it turns out, like when you think about it, that it's finance, that media, like TikTok, and like if I had to put my finger on like what is it specifically, what is the specific use case that I would be really excited to see, it would actually be really hard. Maybe I'm just wanting to have more interesting infrastructure, but I don't know, Ricardo, what do you think?
Well, I think one of these goes back. I feel like we may even have discussed this a few times. I think this comes back to my natural distrust of organizations in general. But yeah, finance is definitely one provable and preferably in a private manner. But even when we're talking about even basic data analysis, like say me wanting to get quotes from 3 health insurance companies without having to send everybody my documents, or how they work right now, which is pretty much optimistically, where I say like, yeah, I don't have any pre-existing conditions. And then if they realize they have one, they bounce me, something like this, right? To even the point where at that issue, you get to a dispute point where would you have considered this a pre-existing condition or not? Right? Being able to generate these things in a completely private, unarguable manner without me having to send a ton of documents to a whole bunch of companies that I don't know how good care they're taking of them. That will be something that I think would significantly simplify things overall.
Yeah, I guess my point is like, we lament that DeFi is such a big use case because there's other exciting use cases beyond just financial stuff. And like the exciting use case here is insurance company interactions.
Private data analysis, of which the insurance company is just a very visible one because it involves health data,
Yeah.
which is very sensitive. But private data analysis in general, in a provable way, and with the proofs anchored in a global, indisputable settlement layer, let's say, I think would have a lot of potential as well. I don't think we're nowhere near. Never mind the stuff that we would need for this, but the companies that could use it being ready to adopt it.
I'm just excited that we are finally coming to a point in blockchain development where it's technological feasible to deploy large language models backed kittens that live on a blockchain.
Okay, let's dig into this. So, like, how do we deploy large language models on blockchains?
Well, let's start with Cartesi technology. Like people have actually put in, let's say, interference let's say one of the, I think it was Alpaca 7B, using basically Cartesi technology. So they've actually been able to kind of like run and kind of extract, let's say responses from it during a Cartesian computation, right? So it kind of like shows that it is a space that can actually start a role, right? what we then do are completely crazy things, and we have done crazy experiments with kittens and blockchains before. And I'm sure there's some kind of like crazy use case that might actually be valuable to some people in one way or the other, or let's say, yeah, it's possible today in some of them.
Let's dig into that one a bit, because I think it brings us back to shockingly, it brings us back to the original topic of Cartesi. When you say deploying it on Cartesi technology, you basically mean running it on a Cartesi machine.
Yes.
So this is just using the Cartesi VM. It's not interacting with any of the other components. It's just.
Well, you can run it like somebody has already deployed it as a roll up. Build it as a roll up. But
so you could theoretically dispute an instruction or a step
in that, yes.
Yeah. Okay. So how do we get to 70 billion parameters on the blockchain? Because like obviously the thing I'm interested in is having super AI that's completely uncontrollable and has money.
I'm not sure what the kind of like the token per second in CPU single thread is at the moment for 0 billion, but I mean, it really depends on like how you approach the problem, right? But I mean, if it's something where, let's say, you are not like looking for instant answers, I mean, sure, why not, right? Like it might be that you're gonna.
Yeah. No, it doesn't need to be instant. It just needs to make long-term predictions about how to best maximize the amount of paper clips in the universe. But
yeah. and now we end on now to interface with a wallet interface as well. I think it's interesting, right?
It gets very interesting. I like once there's a super AI with a large treasury, that I know where I'm going to be applying for grants. But just quickly, so like, okay, so you can run a 7 billion parameter model. There's a lot of interesting experiments around like basically compiling kind of like not a meta model, but basically just running a whole bunch of smaller models that interact with each other. Um, and that is probably somewhat similar to how the brain works. So I mean that would be an interesting thing to try to somehow do in Cartesian machines, because if you can do the 7 billion, you could then have 40 of those all interacting.
And I think people are already doing this kind of like let's say 18-based simulations and so on, which is turning out to have some interesting things. So I mean, we might call it some kind of like intelligence. I don't know what it would look like, but for sure we should try.
I mean, it's
and give it untraceable wallet
to be clear.
access.
So a 7 billion parameter model is like, where would you rate that in terms of intelligence? Like, if you had to provide a real world analogy, is that like, is that a child? Is that an adult human? What is it?
I don't know, but I can tell you that then a bunch of children can be surprisingly organized once in a while.
So, historically speaking, I don't think it has been the case that more dumb people has led to better decision making, but maybe LLMs will have different dynamics.
Yeah, but anyway, like a little bit like what I've been writing in a presentation recently, like hey, it could feel really be nice. It would kind of like make blockchain fun again, right? Man, if we can stop doing these kind of crazy things, like the crazy people that put out kittens that mate on chain, maybe they can start having telepathy between each other. Maybe they can organize. Maybe they can unionize.
Oh, unionization sounds bad. But so that's right. Maybe another interesting point here is that I also feel this very strongly. I don't know if Ricardo does, but I would sort of assume that like at some point earlier there was a lot more excitement. People had a lot crazier ideas. Partially, it's good that those went away because those ideas were completely unrealistic.
At that time, but there's a subset of the problems that's still realistic.
Yeah, like, well, so a lot of the same ideas, right, are just waiting for like enough performance basically to be viable. So like it's like a classic thing. Like everything has already been thought of in blockchain. It's just like probably not the right time. Like every new chain that comes along, people like pull up all the old ICO white papers and they're like, okay, which one should we try this time? And
Yes,
then they
and
try it.
and this time we can actually, like, let's say, develop part of it together with, let's say, GTP4.
Yeah. But so like but the
No,
question I had relating to this was like, do you think that it's actually do you think the future of blockchain is more Wild Westy, more exciting, more innovative, or is it more regulated, more institutional, less exciting?
I think, like, because human creativity is essentially the Wild West and how culture evolves and so on, I don't think the kind of like this nice AOL like garden is where we're going. I mean, it's gonna be a wild infinite garden of strange electronics and plants and so on, and crazy animals, like my background, which is from Cartesi branding, quite visualizes. I would like to imagine.
Ricardo, what do you think?
Yeah, I'd like to
Yeah.
believe that.
Ricardo dislikes governments, but is very pessimistic about humans' ability to basically usurp them in terms of any
It's
power
not that
distribution.
humans are not. It's not I'm pessimistic about humans' ability to do it. It's just that I think humans are lazy.
Mhm.
And if you give them a yellow brick road that leads in a particular direction and they don't have to stray too far from the path, they're just gonna. It's, which is why my whole theory on this, and it has to deal with privacy as well, is that I suspect there's going to be a kind of like a ghettoized section that is Wild West, and that ghettoized section doesn't like nobody else wants to interact with it because you don't want to touch anything that came out of that because you actually want to be able to, take your tokens and sell them for real world money that you use to buy real world stuff. And if they ever touch that section, then you're gonna get blacklisted somewhere. It's it's how I see this developing. Basically, a further polarization. Right now, we have this kind of gray area of where the difference between the Wild West and the formal regulated stuff is it's a little bit more porous. I think that porosity is just going away, but we'll see.
The counter argument to this is that crypto started out as the Wild West that no one wanted to touch, and in fact, the trajectory has been surprisingly different than what I would have expected. I fully assumed back in 2012 and 13 that we had like a couple years max before like governments realized what was going on and thought it was a completely unacceptable, basically power grab by decentralized community or whatever, and that didn't happen. And so this begs the question of like, will that happen with privacy networks as well?
There
If
is
it does, if privacy networks have enough time to become ingrained enough in, I don't know, billionaires' pockets as tokens, um, then suddenly the world I think looks quite different. But I agree that the general culture is moving towards like being more accepting of more rules and constraints on individual freedom, and that is kind of concerning.
look. I also expected governments in general to step on crypto much earlier. I think I was giving them too much credit. Basically, the main reason why they didn't step on it was because they just didn't get it at all. They had no idea what the hell this thing was. They figured out it was just a bunch of nerds playing with stuff that was going to go away, and then they were shocked about it not going away. Um, Privacy, they understand and they get, and they have been fighting against privacy for freaking decades in various ways, so that they understand. And it is clear that they, at the very least, understand the fact that crypto is let's say, a threat to their sovereignty. You can see it by how quickly they they moved to step on Libra, right? When all these other things came up, they were an outside context problem. by the time that Libra and DM came up, it's like, nope, we know what that shit is and we don't like it, and we can't hit this very particular company here with a stick. So,
It just wasn't USD. Now PayPal is fine doing a USD stablecoin, right? Like that was the problem.
the problem with Libra is that it was a supranational currency.
Exactly.
Basically.
No,
But they could recognize it. They could recognize it at that point.
That's fair.
Bitcoin and Ethereum could be considered supranational currencies that they thought were like toy money. So why even look at that direction?
Yeah, but then again, governments need financial privacy just as much as the criminals do.
And they're gonna do that financial privacy by basically trading in between their own servers that don't publish stuff to these things at large, or like they did with PGP, where encryption of a certain key length was criminalized. Well, at least its export was criminalized. So.
But how are Congress people going to continue insider trading in this decentralized and transparent world if there's no financial privacy?
You assume that everything is going to run on blockchains in the next 5-10 years, and at that point they're probably just going to do it through some shell stuff. Doesn't trace directly back to it. It's not like they're too subtle about it now. Why do you assume that they're going to care?
That's fair. They don't really care. Anyway.
Okay, I think that was the tangent of the day.
That I think so too. I think we should probably call it there. Thanks a lot for Carsten for chatting, and
yeah, thanks for having me on.
Hope to
happy to
chatting.
Bring you back at some point and even discuss this further, because we didn't get into the portals, which seem to be like very purpose specific bridges that I wanted to get into, but we can get into that at some other future time.
Yeah. I think it was good to just have like general Cartesi, what is it sort of stuff, because it's not the clearest thing when you first encounter it.
It's not the easiest to explain sometimes, for sure, but it is like, let's say, just because it isn't easy to explain doesn't mean it's not powerful.
Yeah.
And just one thing that I did want to clear up that wasn't entirely clear, and I'm not entirely sure if Teemu and I are working from different assumptions here. If I have a DApp running on a Cartesi VM, basically it is me running that VM, or someone specifically running that VM. This is not running in a decentralized manner.
It is running in a decentralized manner because it thinks from this point of view, right? Like there's always a sequencer, right, that takes in transactions and makes blocks, right? Blocks of transactions. I'm not talking about state. What the Cartesi machine then is something that goes in and evaluates that block against the state and does the actual computation that ends up in a new state. So when let's say I'm interested, just like with Ethereum, when I'm interested in your blockchain, like, okay, I'm probably reading your state result in one way, or I'm kind of like participating and also double checking myself that's correct. If it's not correct, then there's a dispute happening, right? So it's like, not like I need to keep my laptop open all the time, right? Like in terms of like running a roll up. Of course, there'll be a server somewhere that runs it, but like it's just one participant in a network to make sure that the computation is done correct.
I guess the part that I mean is that on Teemu's scenario of let's say the multiple network large language models, we're not talking about the Cartesi network running these models. We're talking about individuals or companies who may choose or not run a node.
It's just basically like I think things will evolve into network computation providers because like you want to drive down your price, right? And but the difference here is that there's no requirement that let's say you be a virtual machine running in AWS, right? That is something you can run essentially anywhere, right? And there's no, it's permissionless that you can kind of like participate in the verification of that computation.
So I guess it's just a question of like where you're anchoring, right? Depending.
Yeah, exactly. Yes.
And
so
you could be anchoring on a like Cartesi official roll up or something, and participating in some larger computation that is collaboratively being made, or you could anchor on your wife's laptop.
Yeah.
Exactly. That's why I was curious about the DAP PM rollup, let's say, cardinality in there originally.
Yeah. Cool.
Anyway, I guess that's it.
Yeah. Shall we call it?
Thank you everyone for listening. If you did listen, if you didn't, then no thank you.
Screw you.
And we'll see you next time.